All right, welcome everybody. So we're going to start by picking up with that 3.2 notes. So if you'd go ahead and grab those, we're going to finish out the last part of those where we look at coterminal angles and some different things with that. So thing one, we are on this last page, we were talking about coterminal angles. So these are angles that land us in the same spot. We can use different measures, so degrees or radians. We can do positive and negative rotations. We can do multiple rotations. So if I look at this diagram over here on the right, I see that I have a positive rotation of 90 degrees that lands me with a terminal side at my y-axis, my positive y-axis. So 90 degrees is equivalent to pi over 2. I could make a coterminal angle that's an opposite direction rotation, which means it's a negative angle, right? I'm now rotating clockwise, so negative 270 degrees, because when those two angles add together, they should add to 360 or a multiple of 360. So what does that mean? 90 plus 270, that absolute value gives me 360, which means that they are coterminal, okay? Then, if I look at my radian measures, the same thing happens. I have pi over 2 plus 3 pi over 2 gives me 4 pi over 2, which is 2 pi, right? Each of those represent a full rotation. And remember, it could be a multiple of that also. So real quick, I just want to sketch so we have this like same reference point that we're going back to. So I'm just going to create a real quick XY axis, and I'm going to do all my degrees in purple. So for degree measures, I have 0 degrees, 90 degrees, 180 degrees, 270 degrees as I rotate around my circle. And then I'm going to do my radians, 360, in green. So I've got 0 pi. 90 is equivalent to pi over 2 because half of a rotation, or 180 degrees, is pi. So then if I rotate another 90 degrees, that's another pi over 2, landing me at 3 pi over 2. And a full rotation is 2 pi. So whether we're in degrees or radians, we've got this idea of what a full rotation in degrees is, what a full rotation in radians is. Okay? All right, so we want to find some coterminal. We want a positive and negative for each. So I'm just going to create a real quick sketch so we can get that visual of where that angle is. So 150 degrees, we should be in the second quadrant. So there's my angle of 150 degrees. If I now do a negative rotation and rotate the opposite direction, that would create a coterminal angle. So a rotation of negative 210 degrees would give me a coterminal angle. Additionally, I could say, hey, I'm going to rotate around in a positive direction one more time to land at that same spot by taking 150 plus 360. So adding those together, I get 510 degrees. So my two coterminals could be negative 210 and positive 510. All right, so now let's look at a radian. So for radians, all right, we've got 0, pi over 2, and pi. So if I'm thinking about pi over 12, well, pi over 2 is the same as 6 pi over 12, right? That is a different form of pi over 2, right? 6 pi over 12 reduces to pi over 2. Well, that tells me that I'm in this first quadrant, and I'm pretty darn close to that x-axis. So that would be my angle at pi over 12 that I want. All right, well, if that's my pi over 12 angle, I can create a negative angle by rotating the opposite direction. So thinking about 2 pi is equivalent to 24 pi over 12. So a full rotation in terms of twelfths is 24 pi over 12. So if I take pi over 12 and subtract that full rotation, that'll give me my negative angle, which gives me negative 23 pi over 12. That would be my negative rotation. All right, so now if I want to create another positive angle, I could take pi over 12 and add 24 pi over 12 to give me 25 pi over 12. And that would be a coterminal in that positive direction. Okay. The biggest piece of the puzzle here is these last two questions really ask us to pull all of that information together. And what quadrant are we in? What's our angle in radians? Like, how do we convert between our two angles? Coterminals, both positive and negative, degrees and radians. So I'd like you to pause the video now, finish out these last few coterminals. So 24, 25, 27, 28, and then check that you get what I get on A and B below. So go ahead and pause the video, work through those 4 problems, make sure you're feeling good with that vocab before you move on. And when you're ready to move on, we're going to move on to 3.3. So the beginning has a little bit of a warm-up. So we look at how we're rotating, finding those angles, whether they're positive or negative. Okay, and it's kind of a repeat because we started with that coterminal process. So check that you get what I get on this part. Go ahead and pause the video if you need to and work through those, make sense of those, and check that work. But the big focus of today is really our reference angles. So what is a reference angle? A reference angle is the angle that is created from your terminal side to the closest x-axis. So if I had any of these angles, so this is my terminal side here. Let's say that this is side T, okay? My reference angle is created with that closest x-axis. No matter where that angle is, they're creating bow tie angles. That's what we've called them also, okay? Because no matter, we can have the same reference angle in all 4 quadrants. So I can have a 30-degree reference angle in the first quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant, all with a different standard form angle. What do I mean by that? If I have a 30-degree reference angle here, 30 degrees is my standard angle. Well, a 150-degree angle also creates a 30-degree reference angle in the second quadrant because that's the measure to the closest x-axis, okay? So reference angles are always the angle between your terminal side and the closest x-axis. Therefore, they're always less than 90 degrees and always positive. We don't care which direction you're rotating. If you're rotating in a positive or a negative direction, we don't care. We just want to know what's that closest x-axis and how far away am I. So looking at that, let's create a couple different scenarios. So if I have a 150-degree standard angle, that means I'm in the second quadrant. There's my 150 degrees. My reference angle is to the closest x-axis, which is that negative x-axis, and that's going to be my angle of theta. Well, that negative x-axis is 180 degrees, so my angle of 150 is 30 degrees away from that closest x-axis. That gives me my reference angle. That 30-degree angle is my reference angle. All right, so we're going to do these highlighted ones. I've given you the answers for the ones that are not highlighted, so you can check your work with those. But negative 240. All right, so now we're going to be in the second quadrant again. There is my negative 240-degree angle. And my closest x-axis is, again, that negative x-axis. So that's my angle theta. That's that reference angle that I'm looking for. So how far am I away from a negative 180 degrees? I am 60 degrees away from that. Again, I don't care positive, negative. I just want to know how far of a rotation am I away from that. All right, so now let's talk radians. So 7 pi over 6. We've got 0, pi over 2, pi, 3 pi over 2, 7 pi over 6. Well, pi is equivalent to 6 pi over 6, which means I'm going to be in that third quadrant. So there is my 7 pi over 6 angle. So now I want that reference angle to that closest x-axis. Again, doesn't matter positive or negative. So how far away am I from 6 pi over 6? Well, I am pi over 6 away from 6 pi over 6. All right, one more. Radians. All right, now we're rotating in a negative direction. So I'm going to label my axes in that negative direction. So I've got 0, negative pi over 2, negative pi, negative 3 pi over 2. All right, and negative 5 pi over 4. Well, negative pi is the same as, I'm going to write on the other side, negative pi is the same as negative 4 pi over 4. So that means I'm going to be in the second quadrant with a rotation of negative 5 pi over 4. Again, don't care direction, but how far am I from that closest x-axis? I am pi over 4 away. That is my reference angle. Okay. All right. So now we've talked about coterminal angles, we've talked about reference angles, we've talked about creating angles in quadrants. So we're going to kind of review that vocab. So 295 degrees. If I'm creating a 295 degree angle, I am in the fourth quadrant. There's that 295 degree angle. So I am in quadrant 4. What's my reference angle? What's that angle to the closest x-axis? That angle would be 65 degrees. So the closest x-axis would be 360 degrees, and I'm 65 degrees away from that. All right, so now let's think coterminals. Well, I can rotate in the opposite direction to create a coterminal, which would be a negative 65 degrees. I can also rotate around again and say, hey, I'm going to take 295 and add another rotation of 360 to get me 665 degrees. Okay, so thinking about the difference between coterminal, reference, angles. All right, so now we have a measure in radians, but this one's a little bit different, right? So remember, our radians, we usually see them in terms of pi, but they can also be represented as decimals because pi is 3.14, which means 2 pi, right? With that would repeat, continue, which means 2 pi is about 6.28, right? So we can really determine where these angles are as a decimal by just figuring out how many pi it is, right? I can type in 5 pi over 3 and it'll give me a decimal. So I need to figure out what quadrant is 2 pi or 2.3 radians. So I know that it's less than pi, which means it's going to be in the first or second quadrant. So I'm going to create my axes. I've got 0, 3.14, right, because that's pi. Well, then this is half of that. This positive y-axis is half of that. So that would be 1.57. So it looks like this angle would be in that second quadrant. So an angle of 2.3 radians as a decimal would be in that second quadrant because it would be between pi over 2 and pi as decimals. So we're in quadrant 2. What's my reference angle? Well, I'm still looking to that closest x-axis, to find theta. So I would take that 3.14 and subtract that 2.3, right? 3.14 represents that closest x-axis. Subtract how much I want to get rid of, and I get 0.84 radians. Okay. Coterminal angles. We're just going to look in that negative direction. So I could take 2.3 and either add or subtract 2 pi. Well, 2 pi is the same as 6.28, so I could add or subtract 6.28 to get those coterminal angles. That would give me those angle measures. So just because we don't see that pi does not necessarily mean that it's not in radians, but we need to be able to use those values as decimals as well. Okay. All right, last one, 4 pi over 3. All right, back to something that's a little bit more normal. Okay, so we've got 0, we've got pi. We know we're past pi because pi would be 3 pi over 3. So we're in that third quadrant, which means that my reference angle here is pi over 3. I am pi over 3 past that closest x-axis, which means my coterminals, if I rotate in the opposite direction, I'm going negative 2 pi over 3. In the opposite direction, remember it adds, absolute values add to 2 pi or a multiple of 2 pi. Or I can do a full rotation by adding 2 pi, which is 6 pi over 3, to get 10 pi over 3. All right, so we are going to look at how can we also use our calculator to determine these things, okay? But I would like for you to use what you know about your special right triangles to solve and find these angles. So a couple things we need to remember. We've got two types of special right triangles. We've got a 30, 60, 90, and a 45, 45, 90. These have special side relationships. So opposite of your 30-degree side is a side length of 1. Opposite of your 60 is a root 3. And opposite, and your hypotenuse, excuse me, is a length of 2. For your 45, 45, 90, your two legs are the same length at 1. And then your hypotenuse is the square root of 2. So why do we care about that? I'm going to ask you to find the sine of 120 degrees. So what does that mean? That means that if I make my angle at 120 degrees, we would agree that that would be my rotation. Well, now I've got this reference angle here of theta, and that reference angle to the closest x-axis would be 60 degrees, which means I can use what I know about my special right triangles to build that triangle in that quadrant. So opposite of my 60-degree angle, I would have a length of 1. I'm in the second quadrant, so that y distance is positive, right? We're thinking like xy. My adjacent side, sorry, that should be a root 3. Root 3. My adjacent side to that 60 degree would be 1, but it's going to be negative because we're in the second quadrant, right? A negative x and a positive y gets us something in the second quadrant. So then that tells me my hypotenuse is 2. Your hypotenuse will always be a positive, always positive. So using that, I can find the sine of 120 degrees by using the sine of that right triangle that I just created using my reference angle. So the sine of that would end up being root 3 over 2. Type that in your calculator and you'll get that value as a decimal. So if you do the sine of 120 degrees, you will get this as a decimal, which is between 0 and 1. All right, same process. Let's do the tangent of pi over 6. All right, well, 11 pi over 6 is going to be in that fourth quadrant, which means my reference angle here is pi over 6. A full rotation would be 12 pi over 6, which means I'm pi over 6 away from that. Well, to convert that to degrees to kind of make it make more sense, we can multiply by 180 over pi. Pi's cancel. 180 divided by 6 gives me 30 degrees. That tells me that this is a 30-degree angle, which means that y distance is going to be a -1 because we're in that fourth quadrant. This x distance is going to be a √3, and my hypotenuse is going to be 2, right? And something in the fourth quadrant, a point in the fourth quadrant, has a positive x distance, a negative y distance. So now the tangent of that is going to be -1 over √3, opposite over adjacent, which becomes -√3 over 3 when you rationalize it. Okay, work through C and D and check that you get what I get. So go ahead and pause that video. Check that you get what I get. All right, so now what if those aren't special right triangles, right? So we're given a trig ratio and we can find all of these other ratios from that, okay? We need to remember our 6 trig ratios. So we have sine of theta, cosine of theta, tangent of theta, but we also have the reciprocals of that. So sine's reciprocal is cosecant, cosine's reciprocal is secant, tangent's reciprocal is cotangent. All right, so if I know this angle here is theta, it doesn't matter which angle I use as theta as long as I keep it the same for all of these. I know my tangent ratio is 7 over 24, which means my opposite over my adjacent is 7 over 24. Using that, I can use Pythagorean theorem to find my third side. So take the square root of 7 squared and 24 squared, which gives you 25. And now I can find my trig ratios. So now I've got my triangle set up, right? We don't necessarily know what theta is, okay, at this moment, but I can find all of my 6 trig ratios. So sine of theta would be 7 over 25, which means cosecant would be 25 over 7. Cosine would be 24 over 25, which means secant would be 25 over 24. Tangent, 7 over 24. Cotangent, 24 over 7. All right, so using that, we can also find our reference angle of theta in radians and degrees. I always go back to what we were originally given. So if I look at this, this means that the tangent of theta gives me that ratio. So to find that angle theta, I have to take the inverse tangent of that ratio. So the inverse tangent of 7 over 24, make sure you find it in degrees, make sure you find it in radians, right? Make sense of your work. Like a radian measure should be between 0 and 6. A degree measure should probably be between 0 and 360. So making sense of those values. All right, we've got a few more things to do, but you can go ahead and set up cosecant. Here, the thing to remember is that if we're given cosecant, we can think about this as the reciprocal of sine, which means it's hypotenuse over opposite, or we can flip it to make it sine. So the sine of theta would be 12 over 37. Either way, we can set up and build that triangle and then find all of those side lengths and those angle measures. Okay? All right, so now we can do the same thing, but we can be given a point. So if I want to find all 6 trig ratios and a measure in degrees and radians for an angle, I have point P that's at this point 9, negative 12. So if I'm point P, 9, negative 12, I'm in quadrant 4 because I'm positive x, negative y. So here's my point P at 9, negative 12. Okay, so what does that mean? That means my y distance is going to be negative 12. That means my x distance is going to be 9, and I need to find the length of my hypotenuse. Well, Pythagorean theorem, couple things we need to remember. That distance from your origin to that point will always be positive, okay? This is also a Pythagorean triple, a 3, 4, 5 triangle, because I can multiply all those values by 3. Hypotenuse would be 15. And now I have this reference angle here of theta. I can take any trig ratio. I can find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. I can find all of those trig ratios from that, reduce it. I can also find theta in both degrees and radians. So what we see here is the sine of theta, opposite over hypotenuse, is negative 12 over 15, which reduces to negative 4 over 5. Meaning that the inverse sine of theta, if we take the inverse sine of negative 4 over 5, that will give me my angle in degrees and radians. So go ahead and put it in degree mode and do inverse sine of negative 4 over 5, and you should get negative 53.13 degrees, right? Which makes sense because that would be an angle in quadrant 4. In radians, so now you just change your mode to radians. You should get negative 0.927 radians. Okay. So we can use that distance formula to find the hypotenuse. Okay. We can plot that point in our coordinate plane to find our x distance, our y distance, and set up all of our trig ratios. We can find our angle. We can do all the things that we need. So now, for example 1 and example 2, I'd like you to go ahead and build those triangles in those quadrants, find your 6 trig ratios, and check that you got what I got, both here on example 1 and 2, and then also on the answer key that's posted on the home page of Canvas. Thank you all. Have a great day. I'll see you next time.